Hey guys, this was the jam that we did in the live session. For those who missed the discussion, I want you to watch this video to review concepts on atomic structure and how to read information in the periodic table. You're given here an element oxygen. Oxygen has a symbol O, the atomic number is 8, and then oxygen has mass number 15.999, which is to be rounded off, this will be 16. Okay? The number of neutrons for oxygen is 8. How did we get that 8? Neutrons is equal to atomic mass number minus atomic number. The answer for number 1 is neutrons. The number of neutrons is equal to the atomic mass number minus atomic number. 16 minus 8 is 8. So I already mentioned that this is the atomic number, this is the element symbol, and oxygen is the element name. So the answer for number 5 is mass number. To understand the subatomic particles, we're going to use a Bohr model in understanding the atomic structure of oxygen. Inside the nucleus of an atom, you have protons and neutrons. So the number of protons is equal to the atomic number in a neutral atom. So you have 8 protons and you have also 8 neutrons. 8 plus 8 is equivalent to 16. So that also corresponds to the mass number of element oxygen. Around the nucleus are electrons in the electron cloud. So the answer for number 7 is electrons. Number 8 is the electron cloud. This is where the electrons are located. According to Bohr model, there's a specific number of electrons in each energy level. So the first ring could only hold 2. And then the second ring could hold 8. And then the third ring could hold 18. And the fourth ring, if there's fourth ring, could hold 32. Looking at the Bohr model of oxygen, the first ring has 2 electrons and then the second ring has 6 electrons. 6 plus 2 is 8, and therefore this is how you plot the electrons in the electron cloud. So if we're going to count the number of electrons in the outermost shells, we have 1, 2, 3, 4, 5, 6. That 6 electrons refers to the valence electrons of oxygen. And if you're going to look at the periodic table, oxygen belongs to group 16, which is the oxygen group, and that valence electrons is correct. The second activity that we jammed was filling in the information for these elements: atomic number, mass number, number of protons, electrons, neutrons, valence electrons, and nuclear stability. There are lots of shapes here that I use to color code the information in the chart so it's easier for you to figure out what am I referring to. For reference, I use these shapes and the colors for valence electrons, mass number, neutrons, and for atomic number, protons, and electrons information. Okay, here's a column for the atomic number, the atomic mass number, number of protons, electrons, number of neutrons, number of valence electrons, and nuclear stability. So for those who can't remember how to determine nuclear stability, I put here a sticky note on how to figure it out. For example, you have here chlorine atom. The atomic number of chlorine is 17. The number of protons is understood as also 17. The atomic mass number is 35. To get the number of neutrons, you subtract 35 by 17. So 35 minus 17 is 18. So 18 is an even number and proton is 17. Therefore, this element is unstable. If we're going to have another example here, if you have neon as an element that has an atomic number of 10, mass number of 20, the number of protons is also 10 because it's the same as atomic number as well as the number of electrons. And if you subtract 20 minus 10, you will get 10 for the number of neutrons. Using the Bohr model, the number of valence electrons is 8. Okay, it also belongs to group 18, so it's easy for you to figure out that neon is a noble gas, an inert gas, and looking at the number of protons and neutrons, so that is a stable nucleus. So that's how to determine the nuclear stability of an atom. What if the elements, protons and neutrons, are both odd numbers, like nitrogen? If you look at nitrogen, to get the neutrons, you subtract 14 minus 7, and then you will get 7. So the number of protons inside the nucleus of nitrogen atom is 7, and then the number of neutrons is 7. So therefore, it is very unstable. And the last review is knowing the valence electron of an element and identifying what element it is. For example, you have this illustration here. What element is this and how many valence electrons does it have? If you're going to look at the first ring, it has 2 electrons. And then the second ring has 8 electrons. So 2 plus 8 is 10. And then you have one more ring that has 1 electron in it. So this element has 11 electrons. It has 1 valence electron. So looking at this table, what element has 11 electrons and 1 valence electron? So therefore, this element is sodium. And that is Na. So that's all for my review today, and I hope you learned something.